Activation functions. An activation function is a mathematical operation applied to the output of a neuron in a neural network that determines whether and how strongly that neuron should fire.
Think of an activation function as a decision maker for each neuron. It takes the weighted sum of inputs and transforms it into an output signal, introducing nonlinearity that allows the network to learn complex patterns rather than just straight lines.
In image recognition, a ReLU activation function might process pixel values through multiple layers. If the weighted sum is positive, it passes the value forward unchanged. If negative, it outputs 0, effectively filtering out irrelevant features and helping the network focus on important patterns like edges and shapes.
Activation functions are essential because they enable neural networks to approximate any function, not just linear relationships. Without them, stacking multiple layers would be pointless, as the network could only learn simple linear transformations. This concept relates to gradient descent, which uses activation function derivatives to update network weights during training. Activation functions.